Now we have some problems with the chain rule that involve tangents and normals again. So remember we find the equation of the tangent. And the tangent's a straight line, and we want to find need our gradient of our straight line and a point. So we've got our value of x here, which if we take our minus 1/3, substitute it in there, we get our minus 1/3, substitute in for the function, we get 0. So it's actually going to be at the point where x is equal to minus 1/3, y is equal to 0, because we take the 1/3, sub it in there. So there's our point. We just need our gradient, and we get our gradient of our tangent from taking the first derivative, because the first derivative is our gradient function. But when we've got a bracket to the power, we need a chain rule. So the 5 comes down, 3x plus 1 stays the same, subtract 1 from the power, multiply by the derivative of 3x plus 1, which is 3, which gives us a first derivative function of 15 outside of 3x plus 1 to the power of 4. Now to get our gradient of our tangent, we're going to sub that in again as well. So our minus 1/3 gets subbed in, and we get 3 times minus 1/3, which is going to give us minus 1. So the minus 1 and the 1 cancel, gives us 0. So our gradient is 0. So that means the equation of our tangent, well, it's going to be the line y is equal to 0. Because when x is equal 1/3, y is equal to 0. So it's on the axis there. So we're going to get the tangent being y is equal to 0. So pretty boring one, but it's okay. Process is still the same. This time we've got the equation of the tangent to this curve, 3x squared minus 1 all cubed, when x is equal to 1. So again, we need our point and our tangent, our gradient of our tangent. So we get our first derivative. So bring our power down, subtract 1 from the power, the bracket stayed the same, then we multiply by the derivative of the bracket. So that gives us 18x there, and 3x squared minus 1 all squared. So when x is equal to 1, we sub x is equal to 1 into the function. So that gives us the 0.18. So that will be the 0.18. So when x is equal to 1, y is equal to 8. And the derivative there, we put derivative 1 into the derivative function, give us a gradient of 72. That's a big gradient. That's a pretty steep line. That's okay. So we get 1 minus 8 equals 72 outside of x minus 1, because we used our point and our gradient. Subbed it in, and there's our equation of our tangent. Next one here, we want tangent and normal to this curve at the point where x is equal to 1. So again, we get our gradient by using the chain rule, bring the power down, subtract 1 from the power, kept the bracket the same, and multiply by the derivative of 3x minus 4, which is 3. So that's going to give us 9 outside of 3x minus 4 all squared. When x is equal to 1, we get our y value being minus 1. So that's the point 1 minus 1 where that function is. So the gradient of our tangent then, well, we take our 1, we substitute it into this function, gives us 9, and we know our normal must be minus 1 over 9, because the two of them will multiply to give us minus 1. So we take our point and our gradient of our tangent, sub it in, we get 9x minus y minus 10 when we clean it up. Take our from our normal, all same point, except we get a different gradient, minus 1/9. So multiply through by 9, expand that bracket with the minus, and then collect our terms. So there's our two equations for the normal and the tangent, like we did before, except we're just using the chain rule to get our function, our gradient function. This time we've got x plus 3, square root of x plus 3, which could be written as x plus 3 to the power of a half, because we need to differentiate that, bring our power down, bracket stays the same, subtract 1 from the power, and then multiply by the derivative of x plus 3, which is 1, so it's not going to affect it. When x is equal to 1, we get our y value being 2, so that goes through the point 1, 2. Equation of our tangent, we put 1 into that function, so we get half outside of 1 plus 3 all the power of minus a half, and that's going to give us a quarter, which means our normal is going to be minus a quarter. We use both those. We use our point 1, 2, our gradient of our tangent, multiply it on the left hand side, and then collect our terms. For the normal, it's minus 4, so just expand the right hand side and then put everything into general form, and there's our two equations. So process stays the same. Tangent and normal, we get our gradient, we get our gradient of our tangent, and then we can get the gradient of the normal from that. We use our point, we use our gradients, put in the point gradient form. but it's just where we're getting our function this time, and we've got a harder function, so we need to employ a different rule to start to get our gradient function that allows us to get our gradients of tangents and normals.